Hello friends, today we are going to learn what is Wheatstone balancing circuit. It is a derivation for Wheatstone balancing circuit that is called R1 by R2 is equal to R3 by R4. This is the equation today we are going to solve. Okay, so it is it's a Wheatstone bridge circuit. Okay, R1, R2, R3, R4. There are 4 resistance here. Okay, center resistance I am taken as a galvanometer. Okay, so the resistance of galvanometer is a capital G. There are 5 resistances there. Okay, mostly the center circuit, when it is getting balanced, it's going to be negligible. That is the concept today we are going to discuss. Okay, see, I applied the voltage here. It is a plus minus EMF. Okay, I applied here, so I current is going to come here. I current, the I current, according to the Kirchhoff first law, the I current is going to divide into 2 parts, that going to be the I1 and I2. So in this circuit the I1 current is going to flow, in this circuit the I2 current is going to flow. Okay, so I1, I2. The galvanometer current, always it's a small current, Ig current is going to flow because galvanometer is very sensitive, very less current only is going to flow in the galvanometer. Okay, so Ig current is flowing in the galvanometer. Okay, the I minus Ig, I1 minus Ig, remaining current I1 minus Ig is going to flow in this circuit. Okay, so Ig is going to come in this junction. Okay, here it is I2, I2 plus Ig is going to be a I2 plus Ig, so it's going to come in this place. Okay, so A, B, C, D, these are the point. Okay, at C point this 2 is going to come. Okay, so this 2, according to the Kirchhoff law, this 2 going to add and then it's going to come in this circuit. Okay, so in this place we are getting I1 minus G, so I1 minus G. Here I am getting as a I2 plus G, Ig. Okay, Ig get cancelled, I1 plus I2. So we know already I only split up into I1 and I2. So here again I current is going to come. Okay, so I current, I1, I2. Okay, Ig current is going to come in this. Okay, I1 minus Ig, so it's going to flow in this point. Okay, now Ig is going to come in this junction. I2 plus Ig is going to come as I2 plus Ig. Finally in this place I1 is I is going to come. Okay, this is circuit. Now I'm going to do the equation. Okay, so first I'm going to apply Kirchhoff's second law, A B D A. Okay, loop law, Kirchhoff's second law. Okay, Kirchhoff second law, it is called loop law. Okay, so I am taken A B D A, A B D A. Okay, Kirchhoff's second law. How to do the Kirchhoff's second law? Okay, so current direction, take it as a positive. See, it is I1 R, it is the same side, AB is the same side. Okay, so it's plus I1 R1. Okay, now this side it is a plus current side. Okay, BD, it's here also we are taken as a BD. Okay, it is Ig capital G, it is plus Ig capital G. It is a current in galvanometer and it is a resistance in galvanometer. Okay, when we are coming DA, we have this direction, the current is flowing opposite direction. That means you can take it as a minus I2 R3 is equal to 0. Okay, algebraic sum of all voltage is going to be 0. That is a Kirchhoff law, second law it's saying. Okay, now the again Kirchhoff law I am going to apply in another place, that is the loop of BCDB. Okay, the second law I am applying in the loop of BCDB. Okay, it is BCDB, DB. This is the place I am going to apply. First we will see what is BC. So BC, it is the same side, the current is flowing I1 minus Ig into R2, I1 minus Ig into R2. And here CD, okay, CD we are taken as a CD direction, current is flowing opposite side. So I2 plus Ig, it is a minus, will get R3. Okay, so minus times of I2 plus Ig and R3, sorry, R4. Okay, so this is R4. Okay, it is opposite direction, I2 plus Ig into R4, whole together will get as a minus. Okay, so we got as a minus. Again this place we have the circuit as DB, but the current is flowing as BD. Okay, it is minus Ig capital G. Okay, minus Ig capital G is equal to 0. We have two equation. Loop 1 equation I got, we applied the loop 1 A B D A. Okay, we got as this as the equation. Loop 2, okay, B, C, D, B, okay, Kirchhoff's second law we applied, so we got this as the equation, okay. For both the equation Ig is a 0, for both the equation Ig is a 0, the center current is going to be the 0, the center current is going to be 0, then only this going to balance, that time only we'll get as this as the equation, okay. So when the center current is getting 0, galvanometer current is 0, this R1, R2, R3, R4 is going to get balanced, okay, that only we are learning here, okay. So Ig is 0, Ig is 0 means in this equation we'll get I1 R1 minus I2 R3 is equal to 0. So I1 R1 is equal to I2 R3. This equation I got from first equation, from this equation, okay, because Ig is 0, so we have, this is a third equation, okay, this is the first equation, this is second equation, okay. Now second equation Ig is 0. What is going to happen when the second equation, this equation Ig is 0, so here Ig is 0, Ig is 0, Ig is 0, so remaining answer, what are the remaining answer is there in this place, okay. So I1 R2 is there, so I1 R2 is there, okay, because Ig is 0, here Ig is 0 minus I2 R4 is there, okay, and this is going to be 0 is equal to 0, okay. And then we got as this as equation 4, equation 4 we got from equation 2, and equation 3 we got as the equation from equation 1. So we have two equations. The first equation I1 R1 is equal to I2 R3. The second equation I1 R2 is equal to I2 R4. Okay, it is a fourth equation and this is a third equation. Just I am going to divide with third and fourth, this and this, okay. Just we are going to divide 3 and 4, okay, that is the thing we are going to do. Finally we will get as the it is 3 divided by 4, 3 divided by 4, 3 I know it is I1 R1 is equal to it is I2 R3, so this is a 3, and 4 I know it is I1 R2 is by I2 R4, so I2 get cancelled, so R1 by R2 is equal to R3 by R4. It's a Kirchhoff balanced circuit equation. This is a condition, the center circuit is going to be the current is going to flow in a center circuit is 0, okay. This is the time the circuit is going to get balanced, okay. It is a Wheatstone bridge, okay. Thank you everyone. If you like my channel, please subscribe. Thank you.